Welcome back. We're going to look at pandas in Python. It's important for you to understand this. Please fire up your Jupyter notebook and follow along. To begin, we can have pandas there as the heading. And to use pandas, we'll need to import it as PD and also import numpy as NP. We are going to start with series, which is simply a one-dimensional labeled vector. So we can define a series as follows. So using pd.series, and then you pass a list of numbers, can be positive or negative. You can go ahead and print that out. So we see that we have the values and the index. We can check what the values are and what the indexes are. So we can say object dot, and then you say index. That shows you that the index is 0 all the way to 4 on a step of 1. Remember, the end index is not included. That's why the index is 0 to all the way to 3, including the 3. We can also check the values, what the values are, and we see that the values is basically an array of lists of numbers, and they are of data type integers. And as you have seen, that our index is simply numbers. Those are just automatic. We might choose to change that to some sort of labels, and to do that we can specify the desired indices that we want to use by simply having a comma and specify our index. And our index are simply a list of string characters DBAC. So can go ahead and print that out, object 2. If I print it out, we see that now our indices are DBAC, and those are the values. If you decide to say object 2, and then you check the index, you get the same thing. You get the index are now labels, and the values just remain the same. And we might want to select some values from that series. And how to do that? We use indexing. And to use indexing, we say object 2, and then we open a square bracket and we pass the string or the label. So if I execute that, we get it 4. Because our D is, so we are using the index to access the value of 4. And remember that this is, if we, for example, choose to use index 0, we get 4. So basically, we can use either the index numbers, which is 0 to 3, or we can use the labels of those index. So basically, we can either use the number or the label. Also, we can select the values, or maybe we might choose to change a value of a certain value. So what we do, we just use this. We can say, assuming you wanted to change the value of D, index D. So we use the index with the label, and then we assign it to D. If I execute that, we get, now the value of D has been changed to 6. And suppose now we wanted to select using a different way. We can use Boolean expression, and Boolean is simply true or false. So in this case, we can use this greater than, assuming you want to get all the value or to select the values of that series that are greater than 0. So we pass, instead of the index, we use this object 2 is greater than 0. This one we just evaluate whether it's true or false. If it's true, then that going with object 2, then we are going to print out all the numbers that are greater than 0. So we get 6, 7, and 3, because -5 is automatically less than 0. So that's what we get. Also, we can perform some mathematical operations. For example, we might choose to multiply every number that is in that series by 2. So we simply say asterisk 2. That is, any number will be multiplied by 2. So if I execute that, I get 12, 4, 14, negative 10, and 2. Basically, all the numbers have been multiplied by 2. We can do something like division. We can do subtract all the numbers in that series. You subtract 2 from them. You can choose to do a floor division where we don't have the decimals. So you get 3. Notice the difference between these two, a floor division and an actual division. So what's happening here is that this one is the floor. What is happening is that this has been rounded off. So not rounded off, yeah, been rounded off to the nearest 0, to the nearest integer. So that's it. And then you can also decide to check if a certain value is included in a series. And to do that, we use the index, we use the in keyword. And how to do that? We write our index label, then followed by the keyword in, and then our series. This will just evaluate whether it's true or not. Is it in or not? If it's true, if B is contained in that series, then it's gonna evaluate to be true. And if we check something that is not there, if E is not contained, then what happens? We get a false. And you can also convert a dictionary to a series where the key will become the index label, while the values will become the series values. For example, you might have a dictionary called as data with the name of states and some value. So this is the key and the value. I can go ahead and print out that dictionary. And to convert it to a dictionary, what we do, we simply pass, we use pd.series, and then we pass as data, which is a dictionary, as an argument. So you can go ahead and print that out. Object 3, you print that out, you get, it's actually a series, a labeled series, where the states are the index labels or the indices. And you can also decide to add values to that series. And how to do that? We simply use, you assign indexing, you assign that to a certain value. If I execute that and print out the value of object 3, we have an additional value for Kansas, 18,000, and that's how to add. What if now you want to delete a value? Delete value. To delete value, we use the delete keyword. And to use the delete keyword, so you simply start with the delete, del, that's the keyword, and then you use the indexing Kansas. So it's object 3, square bracket, and then you pass the label or the value label that you want to delete from that series. So if I click that, I execute that and print out the value of object 3, I get Kansas has been deleted. And we can have another series where we can have a value NA in that. So basically we can simply convert a dictionary called data which has a none. None simply means it's NA, and we pass that inside the pd.series. So to convert it to a series, we can go ahead actually and print this out, object 4. So basically, as you can see, we have not a number. And if, for example, now we decide to do some addition, to add two series, and we say object 3 plus object 4, we get NaN for Utah and NaN for California. The reason our object 3, as you remember, had Utah, but our object 4 doesn't have Utah. California is NaN. The value of California is NaN, which means because to add two series, we are adding the corresponding values, specific labels. So if you can't perform any mathematical operations, then it returns NaN. So that's why we are getting that. So how would we be able to get rid of NaN such that if California, the value of California was present, we can assign it a value. If it's absent, it's 0. But for Utah, it's in one series but not in the other one, which means we want to get the actual value of Utah. So what we do, we initialize the value of NaN. So it's like we use fill value. If it's NA, if it's NA, then the value would be 0, will be replaced with 0. So if it's missing, then it's going to be replaced with a 0. So we can do this. We use add function. So we write object 4 dot add, and then inside the add function, we pass object 3, comma, and then the initial value of NA, or NA, the value that's going to replace NA. So if I execute this, I find out that California will still remain to be NaN, but the value of Utah will be printed out. So the next thing we are going to look at is the data frame. And data frame in Pandas is simply two-dimensional spreadsheet-like structure. So we can go ahead and add a markdown cell or a text file and have it as a header there. And we are going to start with how to create a data frame. So basically, I can have a header there, construction. So we can construct, how to construct it. So here we can simply convert a dictionary with multiple values for each key and convert it to a data frame using data frame keyword. So first we can have the dictionary which has multiple values for each key, but the number of values have to be the same. And then after that we can convert that dictionary to a data frame using pd.dataFrame, and you pass data, the dictionary, as your argument. But remember, note this is capitalized. D is capital and F is also a capital. So what is happening here is that the dictionary will be converted to a data frame. We can go ahead and print out the data frame, and there you go. You have a data frame that has 3 columns: state, year, and pop. We believe that pop is population. And as you can see, we have the rows have been given some index. From here onward, we are going to the labels for the rows called indices. So now the next thing we are going to look at under data frames is how to add columns. You can have it as a header there and convert to markdown and then paste that. So, and how to add that, to add columns, is actually very easy. All you need to do is just specify the columns that are already existing, and you include a new column. For example, if we wanted to add a column called deaths in our frame 2 there. So basically what we do, we pass data and then columns, you assign them to a list of string characters. And we know that in data we have year, state, and pop, but we don't have dates. We have index, but it's just index numbers. So here we specify the labels for those index or indices. So if we go ahead and print this out, frame 2, we realize that there's an extra column that has been added with all the values being missing, not a number, or basically you can say NA. Now, how do we retrieve columns from our data frame? To retrieve columns, we simply use indexing. And we simply use indexing with the row index state with a column name. So we are passing the column name inside the square bracket. And here, if I execute that, I get the state column. And remember, our rows are labeled, or they have some labeled indices. And this is one way. You can also use frame2 dot the name of that column. For example, if you wanted to get the value of for the column, to retrieve the column called year from frame2, then all we need to do is say frame2 dot year. And this is it's actually the same as how we would select columns in R programming. So if I execute that, we get the year column. That's how to retrieve columns. And to retrieve rows, it's a bit different. We need to use the indices. So there are two ways. It's either you use the label or you use the indices. So for example, we can choose to use the labels. So we can retrieve rows using the name or the position. Those are two ways of how we can get them. So using the name of that index and this lock, it's called frame.lock. Lock, we use the labels. But so I can go ahead and print that out. So basically I get row 3, which has the values. I can see row 3, which has these values. Also, we might decide to use the indices. For indices, we have to use ilock. For ilock, it's like index location. So we use the ilock with the numbers. So if I print that out, I still get the same thing. Remember, this is row 3 because we always start to count from 0. So it's 0, 1, 2, which means that that's that. So that's why we are getting the same output or the same results. We get the same results. And suppose now we want to reassign some values. To reassign some values, we have to pass a set of numbers. If you have like five rows, then you have to pass 5 values for a certain column. And to do that, for example, we might choose to fill the dead column with 5 set of numbers. So we can do this. We can say this one will just select the column det, and we assign it the values using numpy, which is np dot arange and 5 dot. This dot means that the values that we are going to generate here using this are going to be of float type. So if I execute this, we get the values 0, 1, 2, 3, all the way to 4. Remember, we start counting from 0, which means if we pass here 5, it means that we are not going to get to 5. It's going to start from 0 all the way to 4. It doesn't include this value that is inside that has been passed as an argument. So we get those values, and just like that, our column det has been assigned those values. So now, what if now we wanted to insert some sort of values? So instead of having det as just numbers from 0 to, what if we wanted to insert some values to replace those? Another cell, I convert it to markdown, and then we have a level 2 heading. So to insert some data in a data frame, all we need to do, we can choose to have a separate series with some values, and then we use we specify the index. Remember, we have named index here, 1, 2, all the way to 5. We have our columns. And now if we wanted to add column here to change these values, specific values, we can first define a series with how many values? This is 1, 2, and 3. Therefore, we are going to specify for which rows we want to replace the values. So here we want to replace row 2, 4, and 5 with these 3 values here. So to replace that, all we need to do, we are supposed to come and say, we take frame 2, we select our column, date, and then we assign it val, and val is a series with 3 values. And since we have specified the indices we want to replace, then let's see what we get. Frame 2. If we print this out, we find that row 2, 4, and 5 have been, some values have been inserted. And given that we didn't pass values for 1 and 3, those are left to be NaN. Remember, the whole column is being replaced, and we only passed 3, so anything else becomes NaN. Now, what if we wanted to delete some columns? How would we achieve that? We have some columns that you don't need, and you need to delete them. So to achieve that, we'll have that as a heading. First, we can do some manipulations here. We can add a column called Eastern, and we assign it some values where we are taking frame 2 dot state, so that we are checking if state is equal to Ohio. Do you know what this will evaluate to? If your answer is true or false, you are right. So basically, this will just check if in this column any of these are equal to Ohio. If it's Ohio, then it's going to return true. If it's anything else, it's going to return false. So if I execute this, we see that we have a column that has been added called Eastern, and Eastern has 3 trues for 1, 2, and 3, and false for the rest. Now, suppose now we want to delete column. To delete a column, we use the del keyword in Python, and we pass the column that we want to delete. And to do that, we can use this, del frame 2, and then we pass Eastern in that square bracket. Remember, this just simply selects a column. So if it comes after del keyword, then it means that it will be deleted. So I can do that and print out frame 2, and just like that, the Eastern column has been deleted. You can check if using this method, print out frame 2 dot column to check the what columns we have, and as you can see, Eastern is not there, so basically it has been deleted. Now that's the way to delete column using the del keyword. So what if now we wanted to delete or to drop some entries, basically rows? Entries are rows in a data frame. So if you wanted to drop some entries, you can have that as it as a heading. So suppose now we had a series called object, obj. Actually, we can print it out, obj object. So we have a labeled series, and we want to drop some entries. So how to do that? We use the drop function, and so we first call our series, and then we type the word we type dot, and then we use the drop keyword, and then we inside the drop function we specify the label for that index that we want to drop. If I go ahead and type print out new obj, if I print it out, you realize that C has been deleted. So we have A, B, D, E. So that's how to delete an entry from a series. So how do we do it how can we do it in a data frame? Suppose we had a data frame called data, which takes the values 0 to 15 or 0 to 16, not including 16, basically 0 to 16. And we reshape that to be a 4 by 4 to 4 by 4. So basically you're having 4 rows and 4 columns. And we label our index to be these states: Ohio, Colorado, Utah, and New York. And our columns, we name them 1, 2, 3, and 4. So if I execute this and print it out, I get 4 columns and 4 rows. So now, if you want to drop the entries, there are two ways. Do you want to drop some columns or do you want to drop rows? So to drop rows, then we use data.drop. We can do it this way. So here, call our DataFrame dot drop function, and then if you want to drop more than one column, then you pass it as a list. So if I do that and print out data, actually we get 1, 2, 3, 4, and Colorado and Ohio has been deleted or have been dropped. So this is what we get. Now, suppose now you wanted to drop some columns. Here, you have to specify the axis. Remember, in a data frame, the row are considered to be axis 0 and the columns are considered to be axis 1. So, if you wanted to drop the columns, then we have to use the drop function, pass a list of columns that you want to drop, and we specify axis equal 1. So if I execute this, I get our data frame with columns 2 and 4 having been deleted. Hope that is clear. Then the next thing we're going to look at is another way of creating a data frame from a nested dictionary. For a nested dictionary, we can use an example. It's easier to understand using an example, and convert that to Markdown and have it as a header or a heading. So first we can declare a nested dictionary just like that. Here we have Nevada as the key, and then the value is another dictionary. That's why it's called a nested dictionary. So we have year and the value, another year and the value. And then for Ohio, which is the second key, and then inside for the values, we have 2000 and 2001 as the keys inside that dictionary. So I'll go ahead and print that out. So we see it's just a nested, it's actually a nested dictionary. So suppose now we convert it to a data frame. Let's do that and see what we get. So we just pass it as an argument and print it out. So as you can see what happened there, the keys, the first set of keys becomes the columns, the column names, and the second, the keys in the inside becomes the row labels or the indices. And then inside, now the values becomes now the values of that data frame. Hope that is clear. So there's also something else we want to do. Suppose now you want to label this as our data frame that we've just created to be these two to be states. We want to label them. So basically we want to set row and column names. So to do that, we can have it as a header, convert it to Markdown and execute. And first we can set the index name using the following. We can say frame3.index.name, and then you specify that. So we have the name of our index or the rows is years, and we can also set the name for our columns. So our columns will be state, and if you go ahead and print out our frame 3 and execute that, we see that we have our states is Nevada and Ohio, and year is 2001, 2002, and 2000. So we can check the value attributes. If we check the value attributes for this one, actually we use frame.values. If I execute this, we see the values is 241, 1.7, just like that. The values that are inside here. We can also check the index. The index would be 2001. Now the years, it's of integer 64, and the name has been set to be year. We can also do the same for columns, just to have a feel of what we're dealing with. So it's Nevada and Ohio. Data type is object, and the name has been set to be state. And now, the next thing you're going to look at, it's very crucial for you to understand. Because for you to work with the data frames, we need to know how to, we need to know how to join multiple data frames. And to do that, we use join keyword or join. We can use merge and join. But in this case, we'll first look at merge function. That's what we are going to use. Just convert this to markdown and have it as a header. So in SQL, we call it join. So we have left join, outer join. So here we can actually have two sets of data frames. We can have left frame and right frame. It's too much to type, so just copy and paste. So here we have our left frame, which is pd.dataframe. Then we pass a dictionary, and the dictionary is key and takes the value range 5, which is simply 0 to 5, and then another key left value, which takes the value, but the values that it takes is actually a string, a list of string. So you can execute that. I can go ahead and print out left frame. So that's the left frame. Can print out the right frame. So you see it's key, right frame has other values. A quick look at this. We see that we have the key is 0 to 4 for the left frame, and for the right frame it's from 2 all the way to 6. Now we are going to look at different types of join. The first one that we are going to look at is the inner join. And inner join, what it does is simply take what is common between the two data frames that you want to join. And we use the function merge, and this is how it will look like. Merge usually take some few arguments. It takes the left frame, the right frame, and we also specify the on what. How do you want to join those data frames? What is the primary key? We call it primary key in SQL, but here we simply use it as the key. What is common? What is the unique labels that you want to use? In this case is the key. And we also need to specify how. And here is where you're supposed to specify how you want to join them. So in this case, we are using inner join. So if I execute that, we get key. What is common between them is 2, 3, and 4. And then the left value is C, D, and E, and the right value is F, G, H. So basically, it came here, took the value, this column, and added another column there, and only took a set of what is common using the key. The next one we are going to look at, it's the left outer join. So basically, what it does, it just take the left the left frame and then join it with all the matching values based on the key from the right frame. And go ahead and do that. So basically you're getting, using the how is equal to left, and the joining column is the key. So basically, so you're getting key, left values, everything in the left frame will be present, and then anything that matches from the right frame is gonna be passed on to, added on that column, and anything that is missing is gonna be NaN. The next thing you're going to look at is the right outer join. So here, everything on the right will be included, and anything that matches from the left frame will also be added as a column. And if it's missing, then it's gonna be NaN. And we have something else we call full outer join. And full outer join, this one will include both everything from the left and everything from the right frame. And anything that matches is gonna be included in both. But if it's missing from the right, it's gonna be on the right value. Then if no matching key from the left, it's gonna be NaN, and on the left value column, if it's missing from the right frame, then you're gonna have NaN. And then the next crucial thing you're going to look at is how to combine data frames. So here we use what we call concat. Basically, we are trying to concatenate data frames. You can have a markdown cell, execute. So the default is that the objects are vertically appended. If you use the concat function and you pass a list of left frame and right frame, then all it does is just append the values. For example, you can have a comment explaining that, and we can pass a list of data frames inside the as an argument in the concat function. So if I execute this is what we get. So first we'll have our left frame on top, and everything else from the right will be included. And for the key, for anything that is matching between the two, then those will be merged, or will be concatenated in one column, and the unique columns in the two frames will be added as separate columns in the concatenated frame. Now, if we want to specify how we want to join, we add a comma and then axis. We specify the axis, how we want to join, how we want to combine them. So if we specify axis and we say axis 0, meaning that it's by rows, we see that it's simply like using the default one. So basically it's just the same as what we got here. But then now what would happen in case we change the axis to be 1? It's gonna add them as horizontally. It's gonna add them horizontally or combine them horizontally. It's gonna take the left one and the right one and append them horizontally. And that's how we have that. That's what we get. Welcome back. In this second part of Pandas training, we'll first begin with grouping data frames. Here, we use a data set that is already existing. You can download it online from GitHub. And to begin, we first import the data set from our local directory where we saved it. So we import, and we can first check the first few rows, cars dot head. Once you run that, you see the several rows. There are several rows, the first 5 rows, and as you can see, we have several columns. We have model, the model of the cars, MPG, number of cylinder, displacement, HP, DRAT, WT, QSEC, VS, AM, gear, and carburetor. We can check the shape of this the data set. Remember that this is a data frame. So if we check the shape, we see that we have 32 rows and 12 columns. We can also check the basic statistics, descriptive statistics, empty cars, describe. So this function .describe gives you some basic statistics: count, mean, standard deviation, the minimum, 25%, 50%, and 75% quartiles, and the maximum. So we can also check the mean, empty cars, mean. If we check the mean, what Pandas will do will simply go to all those columns you have and check for all those numerical columns with numerical data type. Then it's gonna get the mean. That's why it's giving you an error. So that's it's saying ensure that you just select the columns that are required. But this for demonstration purposes, because sometimes you might have something like ID, which is numerical, and of course you don't want to conduct mathematical operations. You don't want to get the statistics of ID. The next thing we can have a look at is we can get the mean using different axes. Suppose you want to get the mean for the rows alone, or you wanted to get the mean for columns alone. That's where we introduce axes. So for example, using our mean example, you can just copy and paste here, and inside the bracket you pass an argument called axis, and you say axis 0. Doing that, axis 0, it means that you're getting the mean for the columns. And if you try to do the same for axis 1, let's see what happens. You still get the mean row-wise, but does it really make sense? No. You can't say that you're getting the mean for the rows, because what is this plus this plus this? You can't get the mean for the rows because it doesn't make sense. But anyway, for demonstration purposes, if you want to get the rows, the mean for the rows, you use axis equal 1. That's for demonstration purposes, but in this example, you can't do that. So the next thing you might want to do with the data, you might want to plot a histogram. A histogram, we use the function .hist. But remember, you have to select the column that you want to draw a histogram for. So if I execute that, we see that as a histogram that has been generated for the column MPG. And how many bins do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 10 bins for the histogram. So that's a very basic way of just plotting a histogram. And for that, you can also use a different method to plot the histogram. You can also use this. This is another method where rather than using the indexing, you can use dot mpg to select the column that you want, and you use the .hist function. So if I execute that, I get the same thing. Now we go to our group by demonstration here. Now, to group, we need to specify the variable of interest, and we are going to use group by function. So you first call your data frame, then you say dot, then you use the function group by. So this is our data frame, group by function, and inside the group by function, you specify the column that you want to group by. And the group by, once you store it as grouped by cab, in this case, we need to do a certain operation like mean. So in our case, if we get the mean of a group by, then it's like we're getting mean for different categories as per the cab column. So if I execute this, we see that we have cab 1, 2, all the way to 8, and we have the different columns. So it's like you're getting the mean of MPG for cab equal to 1 equal to 2 all the way to 8. And suppose you wanted to group by more than one category. All you need to do is pass the columns that you want to group by as a list inside the group by function. And now we can check the mean for the group by the two category we just got. And actually you can have a comment just above that, which is very important, because once at some point you might want to come back to your code and you might not remember exactly what you are trying to achieve. So it's always nice to have comments. So if I execute that, you realize now you have grouped by two columns, carburetor and whether it's automatic or manual, AM, and for the different numerical columns. Next, we can compute statistics aggregated over certain groups. To do that, we'll use a NumPy function or NumPy library as follows. So you first import NumPy as NP, and then we already have the group by the two columns. So, and then we want to aggregate, we want to get different statistics. So here we want mean and standard deviation. So we need to call NumPy and then mean NumPy, which is np.std, and you pass them as a list inside the agg or aggregation function. And if we run this, we get several things. So for each column, we get mean and standard deviation. And the mean is for the grouped categories for the by two columns, cab and AM. Also, you might want to count the number of cars in each combination of cab and AM. So to do that, we use .count function and ensure that you select the right column. So here we call our variable that you created earlier, grouped by cab and AM, and then you select cab and then you say .count, and you don't have to pass any argument inside the count function. If I run that, I get the count for each tabulator based on AM. Is it automatic, which is 1, or manual, which is 0? The next thing we can do is plot the count. And to plot the count, we will use a library called matplotlib, and then we call pyplot as plt. So that's the library we are going to use, and in that library, we can use pyplot and we import it as plt, and we use the following code to plot. Too much to type, so just copy and paste it there. But for your understanding, I would suggest that you type it out. If I execute this, I get this. So we have in the y-axis we have count, and the x-axis we have the tabulator, and we have AM. This is a stacked bar chart where we have the green part representing 1, which means that it's automatic, and the faint, it's a bit faint, represents 0. And that's how you can be able to plot the count. The next thing we might want to do with data frames and series is performing arithmetic operations between data frames. So the first thing we can do is what we call broadcasting. Suppose we had an array called R, which takes the numbers, the float values 0 to 11, and has been reshaped to a 3 by 4 array. So if I execute that, we see that it's a 3 by 4 array. And suppose we wanted to get the difference, to do some sort of operations where we want to subtract row 1 from the original array. To achieve that, we say array minus array first row we use indexing to select the first row. If you get subtraction, we see that what is happening here, we are taking the first row minus the first row, you get 0, 0, 0. Then you take the second row, you subtract row 1, you get 4, 4, 4. You subtract the second one, the third row, you subtract the first row, you get 8, 8, 8. So each element, it's basically element-wise. The operation is happening element-wise. That's why you're getting that. We can also do the same for, we can decide to add. Assuming you decide to add, we get the same. If you decide to get multiplication, you'll just get the same. It's like you're taking 0 multiplied by 0, then 1 multiplied by 1, just like that. And then go to the second row, multiplied by first row. So it's 0, 0 times 4, 1 times 5, just like that. We can also do the same for a data frame using broadcasting. So suppose we had a data frame that takes the same numbers and same array and convert it to data frame, and we specify that the columns is B, D, and E. What this function will do, list, this will convert this to individual characters, string characters, and pass them as the columns. Our indices for those 4 rows will be Utah, Ohio, and Texas. So if I execute this, we see that that's how our data frame looks like. Now, suppose we want to subtract a series from that data frame. We can just first define our series here. And our series is simply the first row. Remember that this is how we said we can select a row using an index. Remember we said we can use index or we can use the labels. So this one is the same, series equals to frame dot log. Then you open square brackets and you pass the label. Remember, the label for the first row is Utah. So if you pass Utah there, this will simply give you the same output as when you use iLock and you pass the index. So now if you want to get to subtract the series from the data frame that we have called frame, you simply say frame minus series. If I execute that, this is what I get. So remember, it's like you're taking this minus itself and then row 2 minus this one. So it's row wise. So it's 3 minus 0, 4 minus 1, 5 minus. So you get 3, 3, 3, and the same happens for the other rows. And suppose now you wanted to broadcast down the columns. So to do that, we can define a series that now selects a column instead. So as you can see, we specify our column. So our column will take D for all of this. And now suppose now you wanted to subtract that column from the frame. So if I execute, so here we use the sub function and we pass our series as an argument and we specify that we are interested to do that row wise. So if I execute this is what we get. We get -1, 0, and 1 for all. Because we took this column and subtracted it from the data frame, which means it's 0 minus 0, you get 0. 3 minus 3, you get 0. Oh, sorry, not that one. It's 0 minus 1, 3 minus 4, 6 minus 7, 9 minus 10. You realize you get the first column in the results will be -1. This will be 0 because you are subtracting D from itself, and this one will become 1 for all the entries. A closer look at indexing, we can start with series. We can have a title there, convert it to markdown. So here we have a series that takes 3 numbers, 0 to 3, and the indices is A, B, C, and suppose we wanted to change the value of index 1. So this is index 1. So this value, we want to change this to a different value. Suppose we do this. We want to change the index 1, this one, to D. Let's see what happens. We get an error. This is because index objects are immutable, meaning that they cannot be modified by users. What that means is that once you've defined the index or the indices, you can't change them. So that's why you are getting an error. So what if now you wanted to change it? Suppose you did something wrong and you said this is X instead of C and you wanted to change it. Then we use something we call reindexing. Reindexing, we can use an example. Suppose we had a series called object that takes 5 values and we have our desired indices. So if I do that, that's our series. And we wanted to change these indices to a different letters. To do that, we can simply use reindex function and you pass our new indices as arguments. So if I execute that, I see that the indices for object have been changed. And given that I've passed more than enough indices, the last one will be assigned NaN. It's not a number. So suppose now we wanted to reindex and initialize anything that is missing to be NaN. Here, we'll use reindex function as the indices and we specify the field value to be 0. We can go ahead and run this and see what we get. So in this case, as you can see, the value NaN has been replaced with 0. Again, we might want to reindex and initialize missing values with the forward fill or the backward fill method. So in this case, for instance, we might have an object 3, which is a series with a list of 3 string characters, blue, purple, and yellow, with index 0, 2, and 4. We can go ahead and run that. Object 3, we see that it has 3 values. The series has 3 string characters, blue, purple, and yellow, and index is 0, 2, and 4. Suppose now we wanted to reindex such that we have index 0 all the way to 5, and anything that is missing be replaced with method forward fill. So in this case, we use this method as follows. So here we reindex with 0 to 5, given that this we will only generate numbers 0 to 5 since 6 is not included, with method called ffill, which means that since we have 0, that is blue, but since we don't have 1, it's gonna be prefilled using this method. Anything that is missing, this is the method that's gonna be used to fill that. So if I execute this, I see that we had our 0 to be blue. And given that 1 was missing, then the value for the previous index will be carried forward. So the missing value has been replaced with the previous value. And we see we didn't have 3, so it's replaced with purple. We didn't have 5, so it has been replaced with yellow. And that's that method. You can as well decide to use a different method. Suppose we decide to use, for the same one, I can rerun this object 3 to get the series, and you see that it's blue, yellow, and purple. Is blue, purple, and yellow with index 0, 2, and 4. So if I decide to use a different method, backfill, and run this, let's see what we get here. So here, you see that the missing values are being filled with the next values. So in this case, since 1 was missing, index 1 was missing a value, then has been replaced with purple. I hope that is clear. So we can have a closer look at indexing. So a closer look at indexing, and to look at this, we can use a frame, a data frame that takes the values from 0 to 8 and reshape that into an array, and the index is A, C, and D, and the columns are named Ohio, and that has been converted to a data frame. So I can go ahead and run this and print it out. So we see that we have a 3x3 data frame with 3 columns and 3 rows. So now, suppose we wanted to reindex such that we have A, B, C, D. Remember, we don't have a B. So if we decide to reindex like this, then it means that D will have NaN. Can go ahead and execute that. B, since it was missing, it's NaN for the whole row. And that's a way of reindexing the rows. You have to specify index. But if you wanted to reindex the columns, then we can first declare some states this way. And then after declaring some states, which is a list in a list, and as you can see, we have Ohio, Texas, and California in our frame. But the ones that we have declared here, we have Texas, Utah, and California. And we can reindex. To reindex the frame, we simply say frame.reindex columns equal state. Let's see what we get after we execute this. We see that we have now replaced the columns Texas, Utah, and California. So we have our Texas there, which takes our frame. You see, this is the frame. We have our Texas because we have the Texas there in our list of states. We don't have Utah in our frame, so meaning that Utah will be NaN, and then we have California, which had the values in that column 2, 5, and 8. So we have those, and just like that, Utah has been added with the values NaN. So, and that's how to reindex a column. So the next thing you are going to look at is how to perform series indexing. For series indexing, you should realize that series indexing in Pandas works the same way as NumPy indexing. Remember, a data frame or a series is simply an array, and Pandas is built on top of NumPy, so they work in a similar manner. So you can have a comment there, and the only difference is we only use index values in place of just integers. Remember, for NumPy arrays, they don't accommodate index values. We just use integers. So, but in Pandas, we can use the values or the labels. So suppose now we had an object, a series that has four values, and these are the indexes A, B, C, and D, and we wanted to get the second object in that series. So we can go ahead and just print that out. Now suppose that we wanted to get the second object. For example, we want to get this one. So we see that it has the index B. That is B is the index label, but in reality, the index is 1. So we can get this value in 2 ways through indexing. First is using 1 in the square bracket, or we can use the label B as follows. If you go ahead and execute these, you realize you get the same thing, because Pandas series allows us to do indexing using the integer or the index labels. Also, we can do slicing, and slicing we can use index labels to specify the start and the end. We can do it as follows. So we can specify the start index and the end index using the labels. So if I execute that, I see that I'm getting B, C. Remember, when we use the labels, both are included. But if we decide to use slicing using the index values, then it's going to be different. For example, if I go ahead and do the same and use object, then we know that B is index 1 all the way. We know that C is index. So if we do this, you realize this is what we get. We get 1. Mark the difference. If we use the index labels, then both are included. But if we use the index values, only the start index is included and the end index is not included. So in this case, 2 is not included. Hopefully it's clear. But if you have any question, please post them in the comment section. Now we can go ahead and look at DataFrame indexing and see how we can achieve that. So suppose we had a data frame and we wanted to retrieve more than one column, because the data frame will allow you to index to retrieve more than one column. So suppose we had that data frame with 16 values starting from 0 to 15 and is forming a data frame, 4 rows and 4 columns. And the index are just like this, with Ohio, Colorado, Utah, and New York. And the columns are 1, 2, 3, and 4. So we can go ahead and print this out. So we see that's our data frame. If you wanted to retrieve a column, all you need to do is just do the normal indexing and use the column label just the way we did for indexing. So here we retrieve one column called 2, just this way. We can go ahead and run that. We get just the second column. We can get the fourth one 4, just like that. So we see this is what we get. If we wanted to retrieve more than one column, then it means that we need to pass a list of columns that we want to retrieve. If we wanted to retrieve 2 and 4, so you see we have retrieved the 2 columns. And we can also do slicing using the column names by simply writing the first column all the way to column called Utah, and this is colon in between to enable you do the slicing. So here we've actually been able to get the 2 rows. We're getting 2 rows. So here we're using slicing with the index labels. And just like that, we've been able to get all the columns for the two rows with the index Colorado and Utah. Also, we might be able to do slicing with row numbers. And to do that, we simply use this. You can say data. The start index is not provided, but the end index is provided. But remember, when indexing and you're using the numbers, then you won't include, when slicing, it won't include the end index, which means that this, which happens to be row 3, will not be included. So it's gonna get all the rows up to the row with index 1. So that's why you're getting 2 rows, which happens to be rows with number 0 and 1. 2 is not included. That's why we only get 2. We can also do filtering, and to do filtering, we only use something that's gonna give us either true or false. For example, here we want to get all the rows or the data, all the rows for which column 3, the column named 3, is greater than 5. So in this case, we see that the the only row that violates that rule is the first one. So meaning that when we execute, we are supposed to get these 3 rows. Let's go and confirm if that is the case. So execute, I get the 3 rows because the first row, the value for the third column was less than 5. So that's how we actually do filtering. We can play with this. We can say maybe less than 5 and execute. We see we get 1 row for which column named 3 is less than 5. And we can also use a Boolean statement to generate either true or false. For example, we might want to check, we might want to convert data, the whole data set or the data frame to be either true or false if the value is less than, any of those values are less than 5. And to do that, we used this statement. So it's data, and then you used the less than operator and 5. So if I execute this, you get a data frame with either true or false. So if you decide to incorporate or maybe to change everything to 0, you can simply do this. You can actually replace everything that is less than 5 with 0. And to execute that, so anything that was true has been replaced with 0 because that's the condition we set. So what we are doing here, we are taking in our data frame called data, anything that is less than 5 is being replaced with 0. And that's exactly what happens there. The next thing we might want to do is select a bunch of rows and columns. For example, if we wanted to use something called lock and iLock with our data frames, we convert that to Markdown. So I want us to do this and see if we want to use the location lock data.lock. This one is simply gonna select some specific rows based on their labels. For example, we might get Colorado for rows for columns 2 and 3. Is Colorado for which columns? 2 and 3. So we expect to get 5 and 6. Let's execute that and see. You get 5, 6. Another example we can use is this one. Suppose now you wanted to get column 2 and 3 for 2 states, Colorado and Utah. All we need to do is use lock, and then we pass 2 sets of list for the specifying the rows that you want and the columns that you want. So if we execute this, we get row 2, column 2 and 3, and row named Colorado and Utah. And then we might as well decide, instead of using the labels, we can decide to use iLock or the actual values. So for this one, this means that I want to select row, this is row 3. If I execute this, I get is a column, all the columns, but for row 3. Row 3, because it's this 0, 1, and 2. So this is what I'm getting from this example. And suppose now you wanted to get all the rows before Utah and return only column 2. This is what we use. You realize that before comma, that's why we specify our rows, which rows we want to select, and after the comma, we specify the columns. So here, we want to get anything all the way up to the row called Utah. So if we execute this, we see that we are getting row 1, row 0, 1, and 2, and we are getting the values from column 2. I hope that is clear. Thank you for watching. See you in the next part of this Panda tutorial. Welcome to this third part of Pandas training. In this part, we'll talk about hierarchical indexing, and we're going to start with series. Hierarchical indexing enables multiple index levels on an axis. You can have more than one axis. You can have more than one index levels on a single axis. For example, you might have the following series. In this series, it contains 10 randomly generated normal distributed values, and on the first level of index has A, B, and C, and the second level of the indexing has the values 1, 2, 3, which are the labels. We can go ahead and execute this. So as you can see, is a series with two levels of indexing. We have the first index which has A, B, and C, and we have another level, second level, with the labels 1, 2, 3. Now suppose that we wanted to access B. How do we do it? We first do something we call partial indexing. You want to access only one section or one index based on the first index level. So here we can use data, that's our series, and then we do the normal indexing, and inside the square brackets we specify our label for the first indexing. If I execute this, I get everything that is contained in B. So B has all this. So this is what's being selected. We can also do slicing. We can select multiple indexes or values. So in the first level, we start with our start index, and the last one is C. So it's from B to C. So basically you want to access B and C. And that's basically how to do the slicing. To access the series elements based on the first level of indexing. Now, what if we wanted to get some values based on the second index level? So suppose we wanted to get a subset based on the second index level of the second label. So this is how we do it. So the first, if we have a comma, the first part represents the first index, and the second part represents the second index level. So if I execute this, I get A, B, C, D. So basically what's happening here, I'm getting this value for A, for B, and this for C, and this for, so that's why you're getting only one for each. Then there's something else. Because we have hierarchical indexing, we can do something we call series stack and unstacking. Basically is converting the hierarchical indexing in series to be rows and columns, or rather two-dimensional. So to achieve that, we can use unstack function to convert them into rows and columns. And this is how. So we've come from our original, which had two levels of indexes or indices, to rows and columns. So here, the second level becomes our column, and the first level becomes our our row indices. And then what if now we wanted to go back from data to, we wanted to go back from this back to our original hierarchical series. So here, because you see, as you can see, data is in series. But if it happens that you stored this maybe into a data 2 and execute and we run that data 2, this is what you get. Now, if you want to go back to this kind of data or hierarchical index series, so this is what we do. We say data2 dot stack. So you see, we went back to our original format. The next thing we are going to look at is hierarchical indexing in data frames. Remember, data frames have two axes, axis 0 and axis 1, or rather rows and columns. Now, suppose we had a data frame that uses numbers from 0 to 11 and has been reshaped to 4 rows and 3 columns and has 2 levels of indexing. First indexing for the rows is A and B, and the second level has the labels 1, 2, and on the columns has 2 levels. Level 1 is the 3 states, and on level 2 for each state it has green, red, and so basically it's a green and red as follows. You can go ahead and print this out. So here we have Ohio with green and red, and Colorado with green on the columns, and we have on the rows we have 2 levels, 2 index levels, A, B on the first and 1, 2 on the second. So we can use either axis to retrieve the values, and we can change the index names as follows. So to change the names of those index, we say index names frame index dot names equal key 1 and key 2. So if I execute this, you see that we have for the index, for these ones, we have key 1, key 2. So basically we've renamed this one as key 1 and key 2. We can also do the same for columns. So here we see that we use columns dot names. So basically you are changing the names of the columns. So we have state and colors. So executing that, so we see we have states is the first level, and the second level has been named as colors. So to access the values here, we can access based on columns or rows. To access based on columns, we use the normal format. So we say frame, and then we pass the first level column name, which is like Ohio. If I execute that, I get the information for Ohio, and Ohio has all these values. So it has green and red. So basically you are selecting everything on that column. And remember that Ohio has 2 columns, green and red. That's why you're getting that. And now, if you wanted to select a row based on the second level of indexing, so we use iloc. We can use iloc or we can use loc. So for example, if we wanted to get for A and B, we get 1, 1. So this is how we do it. So we are getting for, since we are using the location, so we are talking about this first one here, A. We are talking about A. Sorry, not A, but rather B, because it starts counting from 0. So 0, 1. So we get state is Ohio and Colorado, and it's green, red for Ohio, and we're using Colorado. So basically what is happening here is that iloc 1 is taking the first row, the first level A, or so this is, so basically it's getting this row. Hope that is clear. The next thing we are going to look at is something we call function mapping. And function mapping, it's very important. And the reason is that Python defined functions automatically apply themselves to each element in a Pandas data frame. However, user-defined functions do not do that. So we need to find a way of applying those functions to these data frames. And how to do that? We use something we call apply function and apply map. So we look at map, we look at apply first, and basically this one will do it row wise or column wise. So suppose we had a data frame that takes randomly generated values, normally distributed values. So we have our values, our data frame with columns B, D, E, and the columns for the 4 states. Now, if we wanted to get the mean for the columns, Then we can create something we call a lambda function that look like this. So we write the keyword lambda, and then we write x, and then x dot mean. So this one, it's like you're taking a single row x, and then you get the mean of that row. So basically we need to apply this function. Sorry, we have a column x that we want to get the mean for, or we want to get a mean for a certain, let's say a series x, and you want to get the mean for that series. So, and how do we apply that? We write our frame, our data frame, and then we use apply function, and we call our lambda function, which is f. If you execute that, so this is what you get. We get mean for each. So basically what happened is that the apply function did apply, actually literally applied the function f, which is getting the mean for any series. You pass it as an argument there. So it has been applied to other columns. Now suppose we wanted to use, instead of just having f, we can pass the axis you want to apply that to apply the lambda function to. So if we put axis 1, it's like you're getting the mean for the rows. But if we used 0, we would have gotten for columns. So axis 0, if you pass axis 0 there, we are getting the mean for the rows, for the columns. And if it's axis 1, we are getting the means for the rows. We can apply a different kind of, for several examples, we can apply a function that gets the maximum and minimum to the columns, and you can still do the same for the rows. In summary, there are those statistics that you can actually achieve. You can apply different. So as a summary, we can incorporate these in our lambda functions: count, mean, standard deviation, all this, describe, sum, whatever you want to do. So the next thing we can look at is apply map. Apply map will apply a certain function to each element in a data frame or a column or a row that you're interested with. Suppose we wanted to get a series of some statistics. Maybe, for example, we can have, we wanted to return minimum values in a certain series or a data frame, minimum and maximum. So we want to return the output as a map or a simple data frame. So here we want to get, for all the rows or columns, we want to get the minimum and maximum. So if we apply this, if we apply, we are getting the minimum and maximum for the columns. Now, suppose you wanted to use apply map, whereby you want to format the output, or you wanted to format the values of a frame in a certain way. For example, we can use these formats whereby everything will, all the values will have 2 decimal places. So basically it's like you're formatting all the values. So because every value will have to be changed, that's why we have to use apply map that works element wise. So to use apply map function, we say frame dot apply map, and then you pass your lambda function that does the formatting. So if I execute this, I see that all the values in our data frame, all these values have been rounded off to the nearest 2 decimal places. And that's basically what you get. And then the next thing we are going to look at is the most vital thing when dealing with data: how to handle missing data. So to handle missing data, we first call something we call NaN as NA. We're importing NaN from NumPy. So we say from NumPy, import NaN, and we can import Pandas as PD. Now, suppose we had a series called data, and we are passing a list. We are creating that series with values 1 and a, which means symbolizes missing, and 3.5 NA, another missing, and 7. So if I execute this, I see that we have some 2 missing values. So how do we handle these missing values? The first thing we can do is simply just drop them. Drop the missing values just like that. If I execute this, I see that the missing values NANs have been dropped. Basically, drop NA function works the same as just selecting the non-missing values, just like this. So we are saying data dot not null. This will return either true or false. So anything that is true will be selected, and basically we get the same thing. But using drop NA function will simply just delete them from our data. So in a series, there are several ways you can detect the missing values or the missing data. And to detect, we're going to use an example. Suppose you have several states, 4 states, and then we also have a list of values, and one of them is missing, and we wanted to create a series from those two, the state being the index, and this being the data that we want as data. So we can create a series by passing as data and declaring that our indices would come from that list states. If I execute this, we get a list, a series whereby for California, NAN is missing. So how do we detect if we have missing values? Yes, here we can see, but assuming you had a million rows or a million elements, you can't possibly just have a look and see it. So we need to use a function called isNull to detect. So this function will just return true or false, and since we know that California is missing, then it's going to be true, but the rest would be false. We can also use another function called not null. So basically we say PD, which means pandas dot not null, and then you pass our object 4 as an argument. So this will simply give you the same thing. It's going to reverse, it's just like a reverse of is null. So is null checks if any of those are missing, and not null simply checks if any of those is not null. That's why we are getting false as the first for California, and the rest are true. So the next thing you're going to look at is how to fill the missing gaps or the missing values. And to do that, we use something we call fill NA and pass different arguments. Now, suppose we had a series and we wanted to replace anything that is missing to be 0. So this is what we use. We say that's our data, and then fill NA, you pass 0 as an argument. If you execute, we see that anything that was missing has been replaced with 0. Now, suppose you wanted to input specific values, we can pass a dictionary with keys representing with the key being the index that you want to replace, and the value being the value that you want to replace the missing with. So if I execute this, I get this. So which means that this was missing and has been replaced with 1, and also this was missing and has been replaced with -1. Also, we can do this. We can say underscore data dot fill NA 0. We are replacing this. We are replacing the NAs here, because if you realize here, let me show you something. We've been doing some replacement, but have we actually changed our data set? No, we haven't changed. But if you wanted to change now in the actual data set, we use this underscore. Underscore is equals to data.fillNA. And since we are saying in place is equal to true, then this will be replaced in the data set that has been saved in has been imported. And now trying to read the data, everything has been, there's no NAs because the NAs have been replaced in the actual data that we read or we created. Also, we can use various methods like just copying the values before or the values below. We can use the forward fill to replace those missing values. For example, forward fill means that the NA, the first NA in index 1 will be replaced with the values before, like this. You see it has been replaced with the value before. Also, we can do the backfill where we get the value, the next value, and replace the missing values. So here we are taking, to replace this value, we of course took the value for index 2. So also we can replace missing values by getting the mean of the other values, non-missing values. So here we'll first get the mean for 1, 3.5, and 7, and whatever we get, we replace the NA, or we fill the NAs. So executing that, we see that we are replacing that with there and another one there. The next thing we are going to look at is how to fill the missing values in a data frame. And how to do that, we can have two data frames. I can print out F1 and DF2. Now suppose we combine those two. So we find that there are some missing values, E and row 3. So column E and row 3 are all missing. So suppose we wanted to replace the missing values with 0. This is how we would have done it. We say fill value equal to 0. So anything that was missing was, so basically we are getting this the sum, and anything that was missing would be replaced with 0. Therefore, we get the values, the sum of the non-missing values. So, and given that we do it element wise, we go and get A0, we add it to A0. So this is exactly why we are getting this. We have for column E, we're only getting the values from DF2, and the same happens for row index 3. We are getting the values for from DF2. Now, the next thing we are going to look at is filtering missing data. Under this, let's assume that we have a data set that takes the first row has numbers, the second row has only one number, and the rest are NAs, and the fourth row has one value missing. So if I execute this, I get 3 columns and 4 rows, and for row 2 has 2 missing values, row 3 has 3 missing values, and row 4 has 1. Now, there are various ways that we can clean up the data with respect to the missing values. We can use drop NA, and if I execute this, we see that we are dropping any row that has some missing values, which is not very good option. Also, we can do some filtering just the way we did here. We are just selecting values that are non-missing by simply dropping rows that have missing values. We can also do this. We can also specify how by saying how equal to all, and this will basically return the NaN only rows. And how to do that, if you execute, we see that drop NA is only dropping those rows with all the values missing. As you can see, we have one such row. Row 3 has all the values missing. So that's what we are getting by specifying how all. This will just drop all the rows with missing values entirely. You can also specify which axis to consider, and we still use our argument how equal to all, and we specify the axis. In this case, for axis 1, anything that is missing entirely will be dropped. So in this case, if I execute this, I get as entirely nothing has been dropped, since axis 1 is only considering the columns and none of the columns is missing entirely. But if we change this to 0, then it's going to consider the rows. If I execute this, you see the row that had missing values entirely has been dropped. We can also, that brings us to the end of this tutorial on Pandas. Please subscribe, like, and share my videos, and do leave a comment on how you found this tutorial. See you in the next video.